Hey everyone. So normally we do JavaScript algorithm tutorials, but this time we're going to be doing Python. It's going to be a easy algorithm challenge just because it's something that's new and got to ease into it. Uh, but it also goes to show that once you master the actual basics of algorithms, the language itself doesn't really matter too much. There are different uh, syntaxes, data structure, representations, but the main concepts remain the same. By data structure representations, I don't mean that the data structures themselves are too different, but rather that how they're called and how they're used, so the syntax is a little bit different. So let's jump right into it. And here we have merged two sorted lists. It's slightly more difficult than merging two sorted arrays, for example, just because you have to deal with linked list structures. Whereas in an array, you just iterate through an array. It's super easy. In JavaScript, you can just use for each, or you can do a for I to n. For Python, you can do for key value in dictionary, or just for element in array. But because it's a linked list, it's a little bit more complex. We're provided a definition of a singly linked list here already called list node. Essentially has two variables. One is the value that we're storing to it, and one is a pointer to the next node. So in terms of the solution, we want to do is we want to loop through and combine nodes from the two lists, depending on which one is smaller. The example that we're given here is, for example, if you have one linked list that says with values 1, 2, and 4, and another linked list with values 1, 3, and 4, we want to end up with 1, 1, 2, 3, 4, 4. Now, what happens if we have two nodes with the same value? Here it seems like it was taking the second node first, but I don't think that really matters as long as the numbers are the same. Yeah, so it's sorted in non-decreasing order, so that means it's in increasing or same order, which means that there could be the same number that's used twice. So that's kind of why if someone says non-decreasing, the thing you want to catch for is why non-decreasing versus increasing. And the difference is the quality. So for example, instead of 1, 2, and 4, it could be, for example, 2, 2, and 4. Because that's non-decreasing, but not necessarily increasing, because the 2 is the same as the 2. Now when we get to the solution, we have, our strategy is to loop through and combine nodes based on which is smaller, and if it's smaller, then we attach it to the new list. So first off, we start off by creating that list node, and that becomes our head. And then the result that we're going to return, we can just have it point to the head. So that way, for example, this becomes the head node, and then therefore the rest of the list is attaching to that. So when we return the first node, we have the entire list. Notice that if we don't keep track of that, if you're at the end, say you're at this node here, you can't really go back to the head. So you want to keep track of that head. So the result is kind of like our current position. You can call it current position, but I like to call it result just to kind of keep track of what we're doing. So while either list is non-empty, which means that either both lists have still items remaining, or at least one of the lists have items remaining, either the first or second, we want to go through this loop. And what we want to do is we want to check to see if the first list is empty, or if the second list is not empty, and the first list value is greater than the second list value. Now, the reason why we want to do this is what happens if we run out of items on the first list. Once we run out of the items on the first list, we just want to attach the remaining items from the second list over to the new list. So for example, if this is say 1, 2, and 3, and this is 5, 6, and 7, the 1, 2, and 3 will start first, and then the 5, 6, and 7 is still remaining. So we want to straight ahead go to adding elements from the second list to it. So that covers this scenario here where the first list is empty. And then we also want to cover a scenario that of the second list is not empty, but the value of the first list current index is greater than the value of the second list current index, which means that the second list here is bigger than the first list. And we want to add from the second list here. Sorry, I reversed that. If the first list is bigger than the second list. So in either of those two scenarios, we want to add from the second list. And we do this by essentially just looking at the next pointer that we have here that points to the next node in the list. And we want to set that to the second list current item. And then once we do that, we want to move to the next node of the second list because we took that value already. So once we take a value, we don't want to keep on checking it. So we want to move forward in that list. Now, if those other two scenarios are met, which means that the first list is not empty, and the second list is either hold on. So for second list, if the second list is not empty and the first list value is greater than the second list value, we want to take from the second list. So it falls to the else if the first list is either empty, so you have nothing